All right, everyone. So, you're sitting in your week 3 lab, cranking out code, and maybe you're wondering, how does all that math theory from the lecture actually connect to this? Well, you're in the right spot. We're going to connect those dots for you, right here, right now.
Okay, let's start with this quote from your lecture notes because it's everything. Vectors, matrices, graphs, probability. This isn't just a random list of math topics. This is the literal backbone of AI. It's how these systems think. So let's keep this idea front and center.
You know, a lot of people see math as this hurdle, right? This thing you have to get through to get to the fun part of AI. But here's the thing. Math is the fun part. It's the actual language AI speaks. It's what lets a system recognize your face in a photo or predict what you're going to type next. So today, let's become translators.
So here's the plan. We'll start with the big why, then dive into the tools. Organizing data with algebra, predicting the future with probability, and teaching models how to learn with optimization. And then we'll bring it all home and connect it straight to your code.
All right, Section 1, AI's mathematical engine. Let's get right into why your lecture notes are basically the key to unlocking how all of this stuff works.
Okay, so the lecture covered a lot of ground, right? Calculus, probability, the whole shebang. But for the lab this week, you're really focusing on 3 absolute workhorses: linear algebra, probability, and optimization. These are the tools you're using right now.
Okay, next up, organizing data with algebra. I know, linear algebra sounds kind of scary, but honestly, it's just how AI sees the world, in neat, organized rows and columns. It's how it makes sense of, well, everything.
So what's a matrix? It's just a grid of numbers. That's literally it. A spreadsheet, basically. But for a computer, this simple grid is an incredibly powerful way to represent, well, anything. A picture, a dataset, even the connections inside a neural network. It's all just numbers in a grid.
And here's where it gets really cool. This right here, this isn't just theory anymore. This is a screenshot from your lab. When you type np.array, you're not just writing code. You are literally building one of those matrices we just talked about. You're taking that abstract idea and making it real.
And then, bam, the payoff. Your code spits out matrix underscore sum underscore CD. You just added 2 matrices together. So what, right? Well, think about this. When you put a filter on an Instagram photo, what's happening under the hood? The app is taking the matrix of pixels that make up your photo and adding another matrix to it to change the colors. That's exactly what you're doing in this exercise. It's the same fundamental operation.
Okay, so algebra gives our AI a way to organize the world. But what happens when the world is uncertain? That's where our next tool comes in, probability. This is how AI makes educated guesses about the unknown.
And again, this isn't just theory. In part 2 of your lab, you're getting your hands dirty with this stuff. You're not just staring at formulas in a textbook. You're actually calculating the odds of something happening, figuring out how much things can vary. You're using probability to make real predictions. You're turning that maybe into a probably.
All right, this brings us to what I think is the real magic of it all, optimization. This is the math that allows a machine to learn. It's the process of getting smarter, of getting better, of looking at mistakes and saying, okay, how can I do better next time?
The main technique here is something called gradient descent. Imagine you're standing on the side of a huge, foggy mountain, and your goal is to get to the very bottom of the valley. You can't see the bottom, but you can feel the slope under your feet. So what do? You take a small step in the steepest downhill direction you can find. Then you stop, feel the slope again, and take another step, and another, and another. That's exactly what gradient descent does.
And look, right there in your code, learning rate. This isn't just some random number. This is you telling the algorithm how big of a step to take down that foggy mountain. If you set it too small, it'll take forever to get to the bottom. But if you set it too big, you might just leap right over the valley and end up on the other side. It's a dial you, the programmer, have to tune just right.
Okay, let's bring it all together. We've got algebra to organize the data, probability to handle the unknowns, and optimization to help the model learn. Now let's see how all these pieces fit together to solve actual problems.
This last part of the optimization lab is so cool because you actually compare 2 different ways of solving the same problem. On one hand, you have the AI approach, that step-by-step walk down the hill with gradient descent. On the other hand, you have the old-school math way, using calculus to find the exact answer in one shot. And this shows you why AI is so powerful. For really complex problems, there is no direct answer. The only way to find the bottom of the valley is to take it one step at a time.
So, when your lab manual says you're learning foundational skills, it's not kidding. What you've done this week, implementing these matrix operations, these probability calculations, these optimization algorithms, this isn't just about finishing an assignment. This is you laying the foundation for literally every single AI model you will ever build. It's a huge deal.
And that's really what this is all about. You're not just reading theory in a lecture anymore, and you're not just blindly typing code in a lab. You're bridging that gap. You now have the mathematical tools, and you know how to bring them to life with code. So the real question is, what problem are you going to solve first?